Okay, the second hand of a clock is 10.2 centimeters long, as shown in figure 4.16. Find the linear speed of the tip of the second hand. So I've written down the linear speed equation. It's equal to the arc length divided by time, which is S over T. And from the problem, the second hand of the clock is that long. That's our radius. And we want to find the linear speed. Let's see. I don't have S. I know the radius. I know the R, but I don't know the S. So I think I'm going to have to use my formula, S equals R theta, to see if we can find it. So arc length is the radius times the angle. Okay, so let's look at this problem a little bit. The angle. This is a little bit tricky. They just assumed that we would realize we were talking about one revolution. So if we're talking about one revolution of the second hand, how long it takes it to get all the way around. Well, then if that is what we're talking about, then theta is 2 pi. Because we're talking about that full circle that it takes the second hand to get all the way around the clock. So, and instead of saying theta was 360 degrees, we went ahead and went with the radian measure. So S equals R times theta. So just multiply 10.2 times 2 and put your pi centimeters. So that is S. Now we can go back to our linear speed formula. It is that S value divided by the time, and if it's one revolution, then it takes the second hand 60 seconds to get all the way around, or 1 minute. So the linear speed is 20.4 pi divided by 1 minute, so 20.4 pi centimeters per minute, or 20.4 pi centimeters per 60 seconds. Oops, that didn't write for me there. So you can do 20.4 divided by 60. Well, let's see, let's put it all in the calculator. 20.4 pi divided by 60 and get 1.07 centimeters per second. Both of these answers are great, and I don't think it told us which way to leave it. So there's that. Okay, now we are talking about a 15-inch diameter tire on a car makes 9.3 revolutions per second. So let's draw our tire. It's a 15-inch diameter, which means it's a 7.5-inch radius. All right, it makes 9.3 revolutions per second. That means that tire is going to turn completely around 1, 2, 3, 4, 5, 6, 7, 8, 9.3, however much a third of that would be, in 1 second. That's our angle that we're talking about here. So our theta is 9.3 full revolutions, full turns per second, and each turn is a full circle. So our theta is 18.6 pi radians per second. We know the radius is 7.5 inches. And let's see what they asked us to find. A part, find the angular speed of the tire in radians per second. Well, angular speed is the central angle divided by time. Central angle in radians is this right here, divided by the time. We're talking about 1 second, radians per second. So that is our angular speed right there, 18.6 pi radians per second. B part, find the linear speed. The linear speed is arc length divided by time. We don't know the arc length, so we have to go over to the side and calculate it like we did earlier. And we have that handy formula. You're going to find that that formula is super handy quite often. S equals R theta. So the radius is 7.5 inches. Our angle is 18.6 pi. So that means that would be 438. Oh, actually they didn't reduce it any. Let's see. I'm not going to reduce it yet then. Let's do 17.5 times 18.6 pi divided by the time, which is 1 second. So the linear speed is whatever that is multiplied together, which is 438.25 inches per second. Inches came from right here, the radius.